Welcome to Survivor Chapter 11 Island, where 4 contestants will battle through a series of challenges inspired by Chapter 13 of Anatomy and Physiology, Muscular Tissue. Only those who truly understand muscles will survive. Round 1. Contestants, welcome to your first challenge, Know Your Muscle Traits. Each of you will be given a definition. Say the correct universal muscle characteristic. Contestant A.
Excitability. It's the ability to respond to stimuli, usually from a neuron.
Conductivity, the ability to propagate electrical signals along the muscle fibers.
Contractility, the ability to shorten forcibly and generate tension.
And elasticity, the ability to return to original shape after stretching.
For deeper understanding, muscles must remain both extensibility and elasticity to allow smooth movement without damage. Round 2 is sarcomere breakdown. Each contestant explains one structure and its role in contraction. Player A.
The Z-disc is a boundary between sarcomeres and it anchors thin filaments. During contraction, the Z-discs move closer together, which shortens the muscle.
Thin versus thick filaments. Thin filaments contain actin binding sites, while thick filaments contain myosin heads, which perform the power stroke.
A-band versus I-band. A-band stays the same during contraction because it represents thick filament length. I-band shortens because actin slides inward.
And the H-zone, the region with only thick filaments. It disappears during the contraction when actin fully overlaps.
Perfect. The sliding filament theory states that filaments don't shorten. They slide past each other, changing band length. Round 3. Next challenge, electric to epic. You must describe one full step of the neuromuscular junction. Contestant A.
The action potential reaches the synaptic knob of a motor neuron.
Voltage-gated calcium channels open. Calcium enters and triggers ACH vesicle releases.
ACH binds to nicotinic receptors, opening ligand-gated Na+ channels.
And if the threshold is reached, the muscle fiber generates its own action potential that travels down the T-tubules.
Correct. Without HCAs, no depolarization occurs. Round 4. Excitation, contraction, coupling. From signal to strength, each contestant will explain a deeper step. Contestant A.
Calcium binds to troponin, causing tropomyosin to shift of binding sites on actin.
The action potential travels down T-tubules and activates dihydropyridine receptors, which change shape.
Dihydropyridine receptors pull open receptors on sarcoplasmic reticulum, releasing calcium.
For the cross-bridge cycle, the myosin attaches, the power strip pulls the actin, the ATP causes attachment, and the ATP hydrolysis reclocks the myosin head.
Correct. ATP is needed not for contraction, but for detachment. Without ATP, rigor mortis occurs. Round 5, muscle metabolism. Match the scenario with the ATP system. Contestant A.
A 3-second sprint uses the phosphagen system. Creatine phosphate donates phosphate to ADP instantly.
A 30 to 40 second burst relies on anaerobic glycolysis, fast but low. ATP yield produces lactate.
A long-distance jog uses aerobic respiration. This has the highest ATP yield, but requires oxygen and mitochondria.
And muscle fatigue happens due to ion imbalances, depleted glycogen, and accumulation of PI cross-bridge efficiency.
Exactly. And for bonus trivia, slow oxidative fibers are fatigue resistant. Fast glycolic fibers fatigue quickly but generate powerful burst.
Contestants, you fought, you learned, and you survived. Almost. One must be voted out. Player A.
I vote for player B because she kept talking about leg day.
I vote for player C because she said a sarcomere sounds like a Pokemon.
I vote for D because she literally said his muscles were tired before starting.
I vote for player A because excitability sounds too excited.
The contestant leaving Chapter 11 Island is Player C.
I regret nothing.
Congratulations to the survivors. You have officially mastered Chapter 11 muscular tissue. Your understanding is strong, just like your muscles.